Hi guys. So today let's see like how can we track the number of bytes allocated on a heap section. So here you can see I have a sample class which is called animal. I have a constructor and a destructor. So where I'm printing simply constructor called and destructor called, and it is having two variables height and weight. So whenever we want to create a memory we want to allocate a memory for this animal in a heap, we use new operator, and to free that one we use delete operator. So, but what if like this animal is getting created in so many other different source codes? So every place we cannot go and do something like this size of star p and add to some global variable. So it will keep a track of like whatever the size which is allocated on a heap, which is allocated on a. It's not exactly a heap because the size of this one will also give the size if even though if it is created inside the scope as well. So in order to track exactly on the heap section, what we can do is, so we can overload new and delete operator. So let's see like how can we overload new operator. So the syntax is very simple. So what we have to do is operator new, and the signature is almost similar to malloc itself. So your white pointer, which is nothing but a malloc, return malloc of this. So just to track, let me print some message inside new operator backslash n. Now, similarly, let me overload delete operator. So delete operator is also very much simply. The signature is similar to free. So what it takes? It will take something void pointer. So let me run here. So brace as operator. So to free, so let me do some check here for a null pointer. So let me do this free. So the same thing, let me print some message here and a delete pointer inside delete operator. So now we have overloaded operator new and delete. So let me compile and execute this one. A.out. So here you can see a new operator is called. So that means a memory is allocated and a constructor is getting called. So in a reverse order, a destructor is getting called and then a cleanup activity is happened. So that is freeing. So now how can you track the number of size? So since like n number of objects are getting created and we need to calculate total size of all this n number of objects. So in order to do that one, let me create a static variable. So let's say long and size is equal to 0. So we cannot do the initialization like this for static variable. Let me do it outside. Animal m underscore size is equal to 0, and we need to tell this is a long. Now let me introduce some function, a static function, static maybe long get heap allocation. So then it returns m underscore size. So then we need to update this size inside this new and delete operator. So let me update here, m underscore size plus is equal to size. That's it. Now even in delete as well. So let me do it here. So now I want to get the size of this object. Like how can we do? It is very simple. So let's take this ptr. So let's take this ptr and again typecast this one to animal star, and again you have to dereference this one. Then you will get animal value, animal object itself. So then execute size of on top of this one. So then decrement the size by that much value. So now we have saved, we have updated the size whenever a resource is deallocated. So now let's see like what is the size, how it grows. We get heap allocation, and after delete also let us print the same thing. So let me execute and that. So here you can see after constructor, so 8 byte is allocated, and after destructor everything is done, so 0 byte. So that means everything is deallocated. So let's see like create like one more object. Let's say animal. So let us take this one here, and let me delete q as well. Delete q, and let me take this one here, and let me update this one to q. And after I delete, what is the value? And after I delete this one, what is the value? So just to understand, let me put some debug message. And step number 1, what happened? So let me format it again. So now let me re-execute this one. It out. So here you can see first time 8 byte is allocated, and second time a new object is getting created, so that time 16 byte is allocated. And whenever a first delete is called, again it decremented and it has come to 8. So once all the object is destroyed, so we are getting 0. So this is one a small way of keep tracking how the memory is allocated in a heap. So the same video is available in YouTube as well. So if you like this video, please share and subscribe. Thank you.